Should we continue with up, or we can go back to the pure section? You have an opportunity to suggest what the first three will suggest. The majority of the three, what they will suggest is what we shall take. Should we continue with applied, or we go to pure section? Okay, pure section, pure, that is where the majority, 2 out of the third one coming. So we go to pure section. So pure, last time we were discussing trig. We're discussing trig. So we had stopped on, I think, number 116. So we can start with question 117. Question 117. Question 117. There are quite a number. There are 8 parts of 117. We shall discuss maybe 2 or 3. The rest I would expect you to go through them. So the first one, they tell us to evaluate. Evaluate. This is sine of 22 degrees, cos of 38 degrees, plus the cos of 22 degrees, sine of 38 degrees. So that is our first question today. They want us to evaluate sine 22 cos 38 plus cos 22 sine of 38. So if you are to evaluate this, you must be able to recall the compound angle formulas for sine, cos, and tan. So if you are able to recall that sine of A plus B, the expansion for that, these are compound angles. This is the same as the sine of A cos of B plus the cos of A sine of B. The expansion for sine A plus B is given as sine cos plus cosine. Then if it is a minus, sine of A minus B is still going to be sine A cos B. A minus, we still have a minus here, cos of A sine of B. That is for sine. Then for cos of A plus B. Cos of A plus B. Can someone give us the expansion for that? Cos of A plus B. Cos A plus B. Lina, what is the cos of A plus B? Cos of A plus B. Cos A plus B. Okay, how about Nansimbe? Nansimbe. What is cos A plus B? Higher Nansimbe, can you say something? Okay. All right. I see it from here. Thank you, Sianzu, Agawa. Okay, fine. So cos A plus B, this is the same as cos cos. Cos A, cos B. If it is a plus, we shall have a minus, sin sin. Sin A, sin B. And if it is a minus, cos A minus B, this is the same as cos A, cos B, a minus, we shall have a plus here. Sin A, sin B. So that is for cos. Compound angle formula is for cos. Then tan of A plus B. This is given as tan A plus tan of B out of 1 minus tan A tan B. We should be able to prove that. We should be able to prove this. Tan of A minus B, if it is A minus B, this should be equal to tan A minus tan of B out of 1 plus tan A tan B. So if it is a plus here for a tan, you'll have a plus, then the sign changes down. If it is a minus, the numerator has a minus, the denominator, you change the sign. So you should be able to prove these ones here. This one is, we should be able to prove that is mathematically correct. And in case you are to prove that, maybe we can prove one and you'll prove the other. Let's say tan of A plus B. We know that tan comes from sine out of cos. So this is sine of A plus B out of the cos of the same angle, A plus B. Sine out of cos gives us tan. So when you use the compound angle formula for sine A plus B and cos A plus B, this is going to be sine A cos B plus cos A sin B. Then out of, for cos, that is cos cos, cos A cos B, a plus, we shall have a minus, sin sin, sin A, sin of B. So from that expression, remember the proof you need is this. We already have a plus and a minus, a plus here and a minus down. So according to the proof, we need a denominator here in the first term, we need the 1. The first term of the denominator, we need the 1. So for us to get a 1, we shall divide all through by cos A cos B. Each and every term, we shall divide it by cos A cos B. So this is going to be sine of A cos of B plus cos A sine of B. In the denominator, we have cos A cos B minus sine A sine B. So what we are doing, we are dividing each and every term by cos A cos B, cos A cos B, each and every term by cos A cos B. This also shall have cos A cos B. So you'll find that up here, cos B cancels. So we shall remain with sine out of cos of A, and that is tan of A, plus, even here cos A reduces, remain with tan of B, out of cos A cos A cos B cos B, that is 1, minus sine out of cos, that is tan of A, sin B cos B, that is going to be tan of B. So the tan of A plus B is actually equivalent to that. Tan A plus tan B out of 1 minus tan A tan B. So using the same procedure, you can prove the tan of A minus B to be this. So why are we going into this? The compound angle formulas, to evaluate this, we needed to have an idea on those compound angle formulas. So looking at what we are given, sine of 22 degrees, cos of 38. plus cos of 22 degrees sine of 38. When you come to your compound angles, the moment you have sine cos, sine cos, sine cos, cos sine like that, you know that is an expansion of sine. But if you have cos cos, then sine sine, cos cos, sine sine, that's an expansion of a cos. So looking at the question, this is sine cos, sine cos. So it is an expansion of sine. It's an expansion of sine. And for the expansion of sines, what we have here, the plus is maintained as a plus. A minus, we shall have a minus. But for cos, if it is a plus in the angles, you'll have a minus in the expansion. So this being an expansion of sine, this plus is going to be maintained. So this is the sine of 22 plus 38. Those are our angles. So it becomes sine of 22 cos of 38 plus cos 22 sine of 38. So when we add these two, we shall get the sine of 60 degrees. And sine of 60 is actually root of 3 out of 2. Root 3 out of 2 is going to be the sine of 60. Okay, these are trigonometry ratios of special angles. Special angles. So under special angles, we have 30, we have 60, we have 45, and 90. So to get the ratios of maybe 30 and 60, we make use of an equilateral triangle. Equilateral meaning that all sides are equal, and even the angles, each of the interior angles is going to be 60 degrees. So if this is going to be 60, this is also 60, even this angle is 60. But if we drop a perpendicular bisector like that, such that this is 90 here, because this side is equal to that side, this angle will be divided equally to give us 30 and 30. Okay, just a minute. Okay, so let's continue. Let's continue, guys. We're looking at special angles just to let us know how this is going to be root 3 out of 2. I know some of our calculators can just give us that answer, And somehow we have not taken time maybe to know how it comes. And with the prevailing technology, AI, ChatGPT, all that, we tend not to push so much. But maybe we can get to know how it comes. So if we have an equilateral triangle, all these angles are going to be 60, 60, and 60. So we're saying if we drop this line, it will also divide the base equally. What is here will be equivalent to that. So if we give this 1 unit, maybe 1 centimeter, 1 meter, even this it's going to be 1. So the whole of that base will be of, let's say, length 2 units. So if this is 2 and it is equilateral, even this will be 2. That will also be 2. All sides are equal. Then when you pick on just one triangle, maybe this, and you want to get the height, let's say, the height of that triangle, you've taken one right-angled triangle, you're going to use Pythagoras theorem, and you have h squared plus 1 squared being equal to 2 squared. This will give us h as the root of 3. Root of 3. So this is going to be equal to root of 3. So in case you want, for example, for 60 degrees, sine of 60, sine of this angle is the opposite, which is root 3, out of its hypotenuse, which is 2. Cos of 60 is the adjacent, which is 1, out of the hypotenuse, which is 2. And then the tan of 60 is the opposite, which is root 3, out of 1, which remains root 3. So that is going to be for 60 degrees. Then in case you're looking at 30 degrees here, the sine of 30 is the opposite, which is 1, out of the hypotenuse. Opposite to 30 is 1. That is 1 out of 2. The cos of 30 is the adjacent to 30, which is root 3, out of the hypotenuse, which is 2. And then the tan is 1 out of root 3. Okay? That is for 30 and 60. Now for 45, we use a right-angled isosceles triangle. Right-angled isosceles. This is what we have. If this is 90, isosceles, 2 sides are equal. Definitely it has to be this side and that side. Like that if this is 90, these base angles will be equal. That will be 45 and 45. Then you'll say if these equal sides have maybe length of 1 and 1, then what will be the hypotenuse? Using Pythagoras theorem, you'll end up with the hypotenuse as root of 2, such that if we are to get the sine of, let's say, 45, if I'm to use this 45 here, it's going to be the opposite, which is 1, out of the hypotenuse, which is root 2. 1 out of root 2. You could even decide to rationalize this times root 2 out of root 2. The numerator is root 2, the denominator is 2. So you can either say 1 out of root 2, or you can say it is root 2 out of 2. That is sine 45. Cos 45 is the adjacent, which is 1 out of hypotenuse. So this is the same as root 2 out of 2. Then the tan of 45, opposite out of adjacent, tan 45 is going to be 1. Then for 90, sine of 90 is a 1, cos of 90 is a 0, and the tan of 90 is actually infinity. The calculator will tell you it is a math error because it comes from cos out of sine. 1 divided by 0 is infinity. Any number divided by 0 is infinity. So tan of 90 is actually infinity. So the root 3 out of 2 here, we're actually getting it from the special angles, which I think you should do. You should be able to master as a student of math. Some things should be part of you. They should be part of you really. When you get to such a value, you don't need again to go through all this. You are expected as a math scholar to know some of these things. So sine of 60 is going to be root 3 out of 2. So we can do another one. Another one we could do there is maybe part 4. Part 4. Part 4 that says cos of 130 degrees, cos of 40 degrees, plus the sine of 130, sine of 40. So when we have cos and sine, we know this is an expansion of cos. And if there is a plus here, it means it came from a minus. For a cos, there's always a change in the sign. So it came from a minus. So the angles are going to be 130 degrees minus 40 degrees. So this now becomes the cos of 90 degrees. When you subtract, you get a 90, and the cos of 90 is 0. As simple as that. The cos of 90 is a 0. Cos of 90 is a 0. Part 5 says tan A minus 1 out of tan A plus 1 if A is 75 degrees. I want you to evaluate that. If A is 75 degrees. So we already know, okay, let me get some suggestions. What do you think we are going to do here to evaluate this? Tan A minus 1 out of tan A plus 1. Tan A minus 1, tan A plus 1. Mr. Mpaji Michael. Mr. Mpaji Michael S. Is that Michael Smith? I think the one up is a tan of 45. Okay, thank you, Priscilla. The one up is a tan of 45. That means the one down, we maintain it, according to Priscilla. Priscilla says that this up here is the same as tan A minus tan of 45. The one down, maintain it as 1 plus tan of A. Correct step, very correct step. That is very, very correct. So what next? Then the tan A down has been multiplied by 1, which is a tan 45. Hey, and I appreciate Anga, you are so good at this thing. You have even been able to see, you've been able to see a silent 1 there. Perfect. Tan of A down has been multiplied by a 1. So meaning it is also tan 45. So we have tan of A minus tan 45 out of 1 plus tan of A tan of 45. Good. But remember, our A is actually a 75 according to the equation. According to the equation, our A is a 75. So this is going to be tan of 75 minus tan of 45 out of 1 plus tan 75 tan 45. Okay. So this is an expansion of tan. An expansion of tan. And we take the sign that is in the numerator, which is a minus. So it is an expansion of tan 75 minus 45. These are degrees. And that will give us tan of 30 degrees. Then from special angles, tan of 30 is actually 1 out of root 3. 1 out of root 3, which you could even rationalize in case you wish to. Rationalize the denominator, and this would give us root 3 out of 3. Okay, so that means that tan A minus 1 out of 1 plus tan A is going to be root 3 out of 3 with our A as 75. Wow, that is good. That is good. And then maybe one last one that has a pi in it. Maybe part 8. Part 8 says cos 2 pi out of 3 cos pi out of 4 minus sine 2 pi out of 3 sine pi out of 4. Huh. Okay. Mr. Mlindwa Benjamin, we have part 8 there. Could you first of all tell us what has been expanded to give us what we have on board in part 8? What has been expanded? Mr. Mlindwa Benjamin. Mlindwa, are you there? Mr. Mlindwa Benjamin, go Mlindwa for now. We are waiting for you, Mlindwa. Okay.
What has been expanded is cos 2 pi out of 3 plus
cos 2 pi out of 3 plus
pi out of 4.
Pi out of 4. Thank you. Thank you, Mlindwa. So we have that cos 2 pi out of 3 plus pi out of 4. So next we just add these angles here. But as you're adding, you first leave alone the pi. You shall get the 2 out of 3 and then add a quarter. The result, we shall put a pi. So 2 out of 3 plus a quarter is what? This is 8 plus 3, 11. Isn't it 11 out of 12? Then pi. 2 out of 3 plus a quarter think it gives that. 8 plus 3, that is 11 out of 12 pi. Now to get the value of that, we already know that pi is equivalent to 180 in degrees. Pi is equivalent to 180. So that is the same thing as cos. Now, 11 out of 12 pi would be equivalent to 11 out of 12 times 180. This is now in degrees. And that gives us, what angle is that? Uh-huh. 11 out of 12 times 180. 165. 165. So we are having cos of 165 degrees. Cos of 165. So are we able to give that using special angles? $165. Because this was because when special angles are acute angles. 165. If we put 180 here, this would be 2 out of 3 times 180. Isn't that 120? I think it is 120. Then the other one is 45. Okay. It is giving us 165. So if we can't get this from special angles, then probably we can express it as a sum or a difference of two angles, two special angles. So we could say, because in this case, we had 120 and we also had 45, but we don't have the ratios of 120. That means if we do this, we shall have to expand this again as maybe 60 plus 60 or 90 plus 30 using those special angles. Or you can say that this is 90 plus 75. But again, this 75, you'll have to split it as 30 plus 45. 30 plus 45. Any of them. So if we are to, okay, let's say this is cos 90 plus 75. So in other words, it is cos 90 cos 75 minus sin 90 sin 75. Cos of 90 is a 0. So this is already a 0. And sine of 90 is a 1. So it is minus the sine of 75. So this is negative sine of 75. So we work on 75 again. So if we do that, 75, we can use that and 45. This becomes negative sine 30 plus 45. For these ones, we have the special angles for them. This is negative sine 30 cos 45 plus cos 30 sine 45. So the negative is out, sine of 30 is a half, cos 45 is root 2 out of 2, cos 30 is root 3 out of 2, sine 45 is root 2 out of 2. So this is negative root 2 out of 4 plus root 6 out of 4. Okay, So in other words, the answer is going to be negative a quarter of root 2 plus root 6. Negative a quarter of root 2 plus root of 6. Okay. So that was question 117. 117. So 118. 118. You can also do some on 118. So those that we have not done on 117, please, you're supposed to sit down and do them. Sit down and do them. If you are in your discussions at a certain time from now, maybe those senior preps, and you're having your discussions, and then a friend calls you on board to do a number, don't say, Mr. Mwima said I sit down. I mean, do those numbers. Do the numbers. So question 118, you could do the first one. They're saying find the value of each of the following. Sin A, sin B plus C, minus cos A, cos B plus C. Find the values of the following: sin A, sin B plus C minus that. So, according to our compound angles, do we have an expansion that states as sin minus cos? Or in other words, what have we expanded to get that? Any ideas? What have we expanded, or what should we do? What should we do? If you have an idea, feel free to either put up your hand or you can text in a chat.
Recording in progress.
Okay. So what are we doing? What have we done to have that expansion? Cos A plus B plus C. Okay, something is missing there. Priscilla, something is missing. But I like the thinking. That is good. Looking at what we have, sin minus cos. We don't have an expansion for that. Instead, we have cos minus sin. So what we are going to do is rearrange. First of all, rearrange what we are given. Cos is a negative. So this is negative cos A, cos B plus C. Then sin is a positive. So plus sin A sin of B plus C. Then we shall come and factorize out a negative. When you factorize out a negative, this leaves us with cos A, cos B plus C. Then the negative we factorized will definitely make this a minus. So that is minus sin of A, sin B plus C. So now we can get an expansion for that. So cos minus sin with our negative out. This is the cos. If it is a minus, then that expansion came from an addition. So it is going to be, the angles are now A and the whole of B plus C, like that. Now, if A, B, and C are angles of a triangle, that should have been mentioned. But if A, B, C, if these are angles of a triangle, like you have this as your triangle, angle A, angle B, and angle C, then when you add them, we should be able to get 180. The angle sum of a triangle is 180. So this now becomes negative cos of 180 degrees. So it becomes negative. There's a silent one here, negative 1. And cos of 180 itself is also negative 1. So the product is going to be a positive 1. So this, the value for this is going to be positive 1. A, B, and C being angles of a triangle. Yes. So that was 118, Roman 1. And in the same way, these other ones we are supposed to expand and just substitute. Expand and substitute. I believe you can do them. I believe you can. I want to do question 120. These other ones I'm thinking you can do them. But if there is one you think we should